In this video, I'm going to show you everything you need to know to work with Git version control in a R project. Specifically, we're going to be working with an RStudio on a Mac computer. This guide is broken down into 3 different parts. Part 1 is initial setup. We've got to get Git set up and configured on your computer. We're also going to create an account on github.com, which is a web service where we can host Git tracked repositories. And then we're going to also integrate with RStudio. There's some built-in Git capabilities there we want to get configured. Once we have that initial setup done on our computers, we can then look at setting up individual projects. And then finally, we're going to look at the day-to-day workflow. Once you're using Git version control on an R project, what does that process look like? Before we get into those details, I want to take a bird's eye view of what we hope to accomplish in this guide. And for that, let's take a look at an example. This is the repository for ggplot2, which is a very popular package in the R community. And a repository is basically just a special term for a directory of files that all belong to a single project. And those files are being tracked by version control. In this example, the repository is being hosted on the github.com server, so anybody could access this repository by going to the URL we have on the screen. And via this interface, we could dig through and look at any of the code files that belong within this project. If we wanted to, going back to the homepage, we could actually download this entire project. There's several options under code here. You can download a zip file, or there's things like cloning that you can do in Git to make a copy of this project to your own computer. So one of the main benefits we get when using a version control system like Git in conjunction with services like github.com is the ability to easily share our work. And then, of course, the primary benefit of a version control system is to track changes to our code base over time. For insight to that, let's click the commit history for this repository. In the world of Git, a commit is like a snapshot of your code base at a given point in time. So each entry we see here in this history represents a single commit or a snapshot that captures how the code base changed at that point. And for each commit, we see a brief description of what happened during that commit. We also see who authored the commit. And then if we click the unique identifier for a commit, it's going to show us the specific details. What files and what lines of code within those files actually changed as a part of that commit. Now, there's lots more I could say about the benefits of using a Git version control system and hosting your repositories on github.com. But if you're watching this video, you're probably already convinced on why you should be doing this. So let's get right into the details of how to set this all up. If you're following along in the notes, the first step under initial setup is confirming that we have Git installed on our computers. If you're working on a Mac, it probably is because it comes with Mac systems by default, but let's double check. The way we're going to do this is let's bring up RStudio, and instead of working in the console, which is where we issue our commands, we're going to switch over to the terminal pane. This provides a command line interface where we can interact with our computer via commands. And the first command we want to run is which git. If Git is already installed on your system, it will report back on the path on your computer where it's installed. If Git is not installed, you'll see a message here, something along the lines of command not found, and you'll need to download Git and get it installed, and I'll include a link on the screen and the notes for where you can do that. Once we have confirmed Git is installed, we're going to issue a few commands to do some initial setup with the Git program. For this, let me go over to the notes. I'm going to scroll down to step 1B, configure Git, and the first 2 commands are going to set a name and an email address to be associated with any of your Git interactions occurring from this computer. So go ahead and copy the name one first in RStudio, making sure you're still in the terminal pane. You can paste that in, and of course you're going to want to update it to reflect your own name. And we'll do the same thing for the email address. Moving on to our next command, we're going to tell Git that any new repositories we create should have a default branch name of main. When working with Git, you can create different branches or forks of your code base, and they're identified by different names. Now, most people starting out just work on a single branch, and we are going to call that branch main just because that is the convention that's used by github.com. So we just want to make sure that this setting is in place. So once again, making sure we're still in the terminal pane, we're going to run that command as is. The next command is going to tell Git how to handle file mode or permission changes in our files. And basically, we want Git to just ignore them. We want Git to track the contents of our files, not the underlying permissions of those files. Finally, we're going to instruct Git how to handle line endings in our files. Different operating systems encode line endings in different ways in files, and the default we're setting here is going to make the most sense for a Mac operating system. That completes our initial Git configurations. And so now the next step, 1C, is we're going to configure how Git works in RStudio. And we're also going to generate an SSH key pair. The SSH key pair is going to be used to authenticate our computers with the github.com servers. To do this, let's go back to RStudio. We're going to go to Tools, Global Options, find the section labeled Git, and check the box to enable version control interface for RStudio projects. It'll tell us that we have to restart RStudio for this change to take effect, so we'll do that in a moment, but for now, I'll just click OK. Under Git executable, it should recognize the path to your Git installation, which should match the path we saw earlier when we ran the command witchgit. SVN is another brand of version control that we're not using, so we're going to leave this blank. And then under SSH key, we're going to click the button to have RStudio generate an SSH key pair for us. For the key type, we're going to leave the default of ED25519. We can see the path on our computer where this key is going to be created. And then finally, optionally, you can add a passphrase for this key, but I'm not going to do that. SSH keys alone are a very secure way of authenticating between servers. And if you want to add this additional level of security, you can, but it's not necessary. So I'll click Create, and I'll see confirmation that my key pair was created. So the first part of the key pair is your private key. You can see the location where that was created. It's got the name of the key without an extension. And then the second is the public key. So again, same path, same file name, but it has a .pub extension. And the way that these SSH keys are going to work is we're going to take this public key and we're going to store it with our account on GitHub. And anytime our computer attempts to make a connection to the github.com servers on our behalf, it's going to check for these keys. It's going to look at the public key it has and see if it's a match for the private key we have on our computer. And assuming it is a match, it's kind of like a lock fitting a key, it's going to authenticate us and give us access to our account. So let's click Close and then click View Public Key to get the contents of that public key. And this is what we want to take and associate with our account on GitHub. So I'm going to leave this window open. I'm going to go over to my browser and go to github.com. I'm currently logged in. If you're not, you can go ahead and create an account, get logged in. And then once you're logged in, click your icon on the top right and go down to Settings. Then on the left, find the option for SSH and GPG keys. Then click the button New SSH Key. And here we want to paste in the public key that we just generated. So going back to RStudio with this window still open, I'm going to make sure I select all of this text, copy it, and then paste it in at GitHub. For title, you can put in anything you want. It's basically just going to identify the key when you're looking in your settings. So I'm just going to say something like RStudio generated key. And then I'll click the Add SSH Key button, and then just confirm I see it listed under my SSH keys. Now with those keys in place, going back to RStudio, I just want to confirm that the keys are set up and I'm able to authenticate with GitHub. So I'm going to click Close. Let's apply our changes. Click OK. And still in the terminal pane, I'm going to run the command SSH-T git at github.com. And the message we want to see here is hi, followed by whatever your GitHub username is. You've successfully authenticated, but GitHub does not provide shell access. If you see a message like this, you know your SSH keys are set up properly, and any future Git interactions you make or RStudio makes on your behalf with the github.com servers should be authenticated with your account there. If you see a message along the lines of access denied, you're going to need to revisit the steps we just took and make sure that you set up your keys correctly. Now, before I forget, when we enabled the Git settings in RStudio, it did tell me I needed to restart RStudio. So let's go ahead and do that. And then we'll move on to our final steps of our initial setup, which is we want to install a R package called usethis that provides some useful utilities for working with Git. To do that, I'm going to run the command install.packages, and then in quotes, usethis. Now notice where I'm running this, I'm no longer in the terminal. When I restarted R, it put me back in the console, and that's where I want to be because this is an R package we're installing. This is an R specific command, so we want to run this in the R console. So let's go ahead and install that package. I think in my case, I already had that package installed, so I see some very brief output. If you're installing it for the first time, you're probably going to see more details. And then once it's installed, we want to make sure it's loaded in our current R session. So we're going to do that via the library command, followed by the name of the package, usethis. And with that, that completes all the steps of part 1, which is just getting Git initially configured on your computer and within RStudio. So now moving into part 2, we're going to look at how we set up a new version control tracked project. The first step here is going back to github.com. We're going to find the plus icon on the top right, and then choose the option to create a new repository. For my example, I've got some example student data I'm going to be working with, so I'm going to name the project Student Analysis. For the rest of the settings, you could skim through the details that are provided. There's also some links to additional information. But for the purposes of this basic example, we could leave everything as the defaults and create our repository. This is the homepage for a brand new repository. It doesn't list any files yet because we haven't added any. Basically, it just has a bunch of information on how to get started working with this repository. And generally, your first steps with a GitHub repository is to get a copy of it on your computer. The way we're going to do that is let's go back to RStudio. And via the file pane, we want to navigate to a directory on our computer where we want to set up this repository or set up this project. You can put this in any directory you want. For the purposes of this demo, I'm just going to put it on my computer's desktop. So I'm going to navigate to my desktop folder, and then I'm going to click the gear icon and choose Set as Working Directory. You can see in my console, it issued the set working directory command, set it to my desktop, and we can see the path reflected in the console is just confirming that we are in fact on the desktop. And this is going to be important because we're about to issue a command that's going to set up our project, and we want to make sure it's created on the desktop or whatever destination folder you chose. The command we're going to use is going to come from the usethis library that we installed a moment ago. It's going to look like this. We're going to say usethis : create _ from _ GitHub, and then in parentheses and in quotes, we're going to paste in the URL to the repository we created on GitHub. So going back to my browser, we're still looking at my repository, and the URL is github.com / my GitHub username, followed by the name of the repository. In this case, that's Student Analysis. So I'm going to copy that full URL, and let's paste it into this function and go ahead and run it. And you can see it's going through several steps to set up a new project. And it's going to launch a new RStudio session. And this new session is now loaded with that new RStudio project that was just created. The way I can tell that is if we look at the top right, there's the project dropdown, and notice it has the name of the project, which in this case is Student Analysis. So when I just ran that create from GitHub command, it took the name of the repository I gave it and also set that to be the name of my RStudio project. If you click the project dropdown, you can see the various options that are available when it comes to working with your projects, opening existing ones, closing the current one, etc. The other thing that we can observe about this window that is now dialed into this Student Analysis project is if we look at the file pane, we can see that our current directory is set to the directory that was created on our desktop. And again, it's named after the project itself, Student Analysis. We can also observe that in the console, you can see the working directory set to Student Analysis. So any R commands I were to issue, either from the console or eventually from a script, would all be relative to that directory. Within the contents of this directory, we could see we've got a special .r project file. This is a settings file that contains all our settings for this RStudio project. If you click this file, it's going to open up your project-specific options. So basically, you can customize RStudio on a project-by-project basis. We don't need to change any settings here, but if we take a look at the Git tab, you'll notice that within this project, it has set the origin to be our repository URL on github.com. So when we use that use this command, we said to create a new R project from our GitHub repo, it set it up so it is connected or configured to communicate with that repository on GitHub. And that's going to be very important because that repository on GitHub and this copy of the repository, which we now have on our computers, these two things need to be connected so that we can transfer files back and forth and transfer Git information back and forth between them. So nothing we need to change here. I just wanted to point that out. So I'm going to click OK. And the next thing I want to take a look at within this project is in the top right pane, we should now have this Git tab, which is where we're going to primarily interact with Git within this RStudio context. And what we're going to see here is a list of files that have changed within this repository. So it's going to be tracking changes to files. Now, in this case, these three changes that we see were triggered when we initially created our project. The first file you may or may not see, it's called dsstore. This is a special hidden meta file that Mac systems creates in directories. And this is not actually something we need to track as part of our repository. So if you do see it, I recommend right-clicking it and choosing Ignore. This will bring up a window to edit our git ignore file, which if we look at the root of our project directory, it's this text file here. So this is just a little window to quickly edit it, and you could see it injected dsstore as one of the files we want to ignore. The other thing that was previously here is a path to a directory called rproj.user. This is a hidden directory, and the reason or why I'd say it's hidden, you'll notice we don't actually see it in the current directory because hidden files are obscured by default, but it does exist, and it is not something we want to track as part of this repository. It has just meta information about the RStudio project itself. So when we created this project, it pre-configured our git ignore file for us to ignore that directory, and then we just added dsstore as another thing to be ignored. Now, once I save these changes, you'll notice that dsstore removed itself from my list because we told Git to not pay attention to that file, so it's not seeing any changes to that file anymore. It does, however, see changes to the git ignore file itself, so this is a file we're going to be tracking. Additionally, it sees the studentanalysis.r project file, which remember, this is just a settings file for the project itself, and that we do want to track. That way, anybody else opening this project would have consistent settings. So long story short, we haven't really done any work in this project yet, but we do have some initial setting files that we can go ahead and create a commit of so we can make sure that our repository on GitHub is in sync with what we now have locally. The process for that is going to look like this. Under the staged column, we're going to click the checkbox for any of the files that we want to include as part of our commit. You'll notice the status changed to an A, which is short for added. And then once I've added all the files I want to include as part of this commit, which right now is just these 2 files, I'm going to click the commit button. And then I want to write a brief message describing what is happening as part of this commit. Then I'll click the commit button. I see some output confirming that the commit was created. I'll click close. And then finally, to synchronize this commit with my project on github.com, I'll click push. Once again, I see some confirmation output. I'll click close. I can close the commit window. And now you'll notice in the Git pane, there's no files listed because there's no active changes. Anything that changed within this project have already been committed and pushed. And if we go back to our repository in the browser and refresh it, we should see the exact same files we're seeing locally. So there's our git ignore file. There's our studentanalysis.r project file. If we go click the commit history, we can see details about the commit that was just pushed. So there was the summary that I added. We could see when the commit occurred. And if we click this unique identifier for the commit, we can see the specific details about what files changed, what lines were added or sometimes removed, etc. So now that we have everything set up, let's just do a little bit of practice. Let's see what our daily Git workflow would look like. So returning back to RStudio, let's do some things we would actually do in an R project. For example, I might start off by creating a subdirectory for my data files. I might also create a subdirectory for my R scripts. And going back to the notes, I do have some sample data we can play around with. So I'm just scrolling down in the instructions. We're under part 3, Git workflow. I have some example student data, so I'm just going to copy that. Go into my data subdirectory. I'm going to create a new file. I'll make this a plain text file. I'll call it students.csv and paste in my sample data. I'll save those changes. And then going into my scripts directory, I'll create a starting script file. And I'll just call this one_import just because typically the first step in any project is importing your data. So that's what's going to happen in this file. And I'll go ahead and write a quick line of code to import my data. And you'll notice the path that I used here is relative to my project's working directory. All right, so the project's working directory is always the root of the folder. So I reference my data folder that's in the root of this project, and then within there is my students.csv file. Even though I'm working within the scripts directory within this import.r file, all of my paths are going to be relative to the working directory of the project. And let's go ahead and run that, make sure it can actually find that data file and load it. So that looks good. It ran without any errors. If we go to our environment pane, we could see that our students object was created. And perfect, there is our data. So I'm going to go back and just make sure I save changes to my import file. And then going back to the Git tab, You can see that Git has recognized the changes I've made to this repository. Specifically, it sees the addition of the data and the scripts directory. And if this were a real project, I'd probably spend a little bit more time writing more code and working with this data before making my next commit. But for the purposes of this example, let's do another commit. Just make sure we're clear on that process. And remember, the first start of the process is staging or adding the files that we wish to include as part of our commit. So I'll do that for the data subdirectory as well as the scripts. You'll notice that once I added those directories, it got a little bit more specific. So it's actually detecting the files within those directories that I created. I'll click commit, write a brief message describing what is happening as part of this commit. Click commit again. And then don't forget that third step. We've got to push the commit to GitHub. And once again, we'll just go back to our repository on GitHub and just confirm that we're seeing the changes here. And perfect, there is our data and our scripts directories. If we click on them, we could see the specific files within those directories. And we can also see now we have 2 commits within our history. Now, in all of the examples I've shown so far, we've been adding new files to our repository, but I want to highlight that once we have files that are being tracked, if we make changes to those files, those are also going to show up as changes within the Git window. Just to demonstrate that, let's make an edit to our import file. I'm just going to add a comment. I'll save my changes. And you can see my Git tab automatically detected that change. It's listing that import file. And you'll notice under status, it has an M, which is short for modified. If we want to learn more about what was actually modified, we can right-click the file and choose diff. And this actually just brings up the commit window that we've seen previously, but instead of creating a commit message, we're going to pay attention to the file list on the left and notice that whatever file is actively selected, it's going to show us details about what current changes exist in this file. And typically the addition of new lines are reflected in green and the removal of lines would be reflected in red. In this case, we just added this first line, so it's highlighting that as green. And then this gray line here just indicates this was an existing line within this file. Now, obviously, I just made a small change here. I injected a line, but imagine you had 100 lines of code here and you had various changes throughout. If you wanted to review the changes there, this would be a way that you could go through that and decide, do you want to commit the changes that you've made to this file? Alternatively, if you wanted to revert those changes, let's say you want to discard them, if you right-click the file, you could choose the option to revert it. So that could be a useful feature. Let's say you were working on something, didn't quite work out as expected. You could always revert it back to its previous state as of the last commit. So the takeaway again with this point is just that Git is not just about tracking new files, but it's about tracking really everything that happens to the repository. When you add new files, when you edit existing files, and also when you delete files, they'll also show up as a change that you'll want to track so that that deletion also occurs on your repository on GitHub. Now that we understand what the Git workflow looks like, let's talk about when you want to make commits. For this, I'm going to go back to the notes down to a section called when to commit. And there's some general guidelines here. A first point in time in which you might want to make a commit is just anytime you're wrapping up a session working on a project. If you make any sort of progress and you're going to step away to something else, go ahead and make a commit so you have a snapshot of your code base at that point in time. Another point I like to make commits is when I get something working, right? I reach a milestone within that project. Go ahead and make a commit. Create that snapshot so that as I continue to work on that project, let's say I mess something up or break it and I want to revert to that previous state. If I have that commit history in place, I can do that. Whether it be doing the simple revert I showed a moment ago, or there are even advanced techniques you can do in Git where you can revert back to multiple commits ago. Another guideline of when you might want to create a commit is maybe you're about to do something experimental. You're not sure if it's going to work. Go ahead and just do a commit. Save your work up to that point. So again, if needed, you could always revert back to it. And then finally, as we talked about in the beginning, one of the benefits of using systems like Git and github.com is you can easily share your code base. So obviously, before you were to do that with a colleague or boss or whatever, you would want to make sure that you create commits with your most recent changes that you want to share so that everything they're seeing on their end when they're looking at github.com matches what you're seeing and working with locally. The final point I'm going to make is there is a lot more you can learn about Git. I have some bullet points here under Advanced Git that you can check out. But everything I showed in this video is really about like 80% of what we do with Git in the day-to-day. So if you can master this, you're off to a good start.